Okay, last 1 minute. Why they're not joining? So many of you said that we want class on YouTube, and now you are not here. Just give me the like button, so I can start my class. Buttons like this. Emojis are there. Okay, this as in the Google Meet, we are having a like button and dislike button. So accordingly, I am understanding your words, and accordingly, we I was teaching you. Okay. So now today we will read the NMR, nuclear magnetic resonance. Nuclear magnetic resonance. So it is a spectroscopy technique. Just share in the group. Ask them to join as soon as possible. Hmm. So NMR is a nuclear magnetic resonance technique in which spectroscopy is it is a spectroscopy. What it is? A spectroscopy technique. So what is the meaning of a spectroscopy technique? Why we are saying this is a spectroscopy technique? So you already seen that IR spectroscopy, UV spectroscopy. These all are called as a spectroscopy technique. So till now, what you found in this spectroscopy technique. So the important thing is that they have a different frequency of energy. Okay, they will have a different spectra. According to that, we are seeing the change in energy of a atom or a particle or electron, and then we are saying okay. Copy. So spectra means what? Spectra means you have level of the energy, and UV spectra means you have different waves of different energies of the atom. So this is the spectra, and this is your atom, and make it little happy because it have a different type of energies. Okay, so what it is? It have a different type of energy, like it have a rotational energy, vibrational energy, or magnetic energy. They have a different type of energy. As you seen in UV, IR, CD spectra, the change in the difference in their energy level. It is to higher energy level. Again, it is coming, emitting some light, that light, that frequency of light, and then you'll say, okay, this molecule will be around this time. Okay. Hope so I am clear about it. This is the basic of spectroscopy that I told. Okay, what is the basic of spectroscopy? That the difference in the energy level, and the if any electron is jumping from here, it is going there, energy, it is excited by one energy. Okay, it is excited by energy, and suppose it is coming down back, it is coming down back, so it is emitting some amount of energy, and that frequency of that energy we will read in a computer or any device, and then we will say this is a etc molecule. Okay, any characterization am I clear now? So this is your atom, and it is a very happy atom because it have a different type of energy, like a rotational, vibrational, or rotational vibration or magnetic energies. Okay, so it have a different spectra, and according to it will jump from lower to higher, higher to lower. And this energy, emitting energy, we will read in the our context. So what is difference in that? So here we will not read directly these energies. The magnetic resonance. Okay, nuclear magnetic nucleus. It is there in the proton and neutron. And this proton neutron, if you'll see, this is proton and neutrons will having their own spinning molecule. So principal quantum number everyone read in your class 11, 12. Yes or no? In that spinning was there, and spinning is because of the quantum number. Okay, magnetic quantum number. Okay, magnetic quantum. So this magnetic quantum number or this spinning means what? The thread like this. The thread, a person who is holding this uh, wool, this is a wool, and this wool was a spin. A spin means you can see and you can imagine how they are making a spinning. Okay, how they are doing the spinning. So spinning will be done by the rotation of a molecule, rotation of an atom in its own axis. This is called spinning. So that will be your mu. In your book, it is written like this, and that is the spinning. Okay, am I clear to you? So that is a spinning, and if you supply one amount of energy and one certain amount of magnetic field, in that magnetic field, it may turns into it may turn into the parallel side to the magnetic field. This is a B, okay, and this is a spinning, or it can turns into anti-parallel side. Suppose this is your B and this is your spinning, atoms of spinning. Are you getting my point? So this is the spinning. So this is a atom. It have a mu. This mu is what? The velocity of the velocity of the atom spinning in its own axis. And this is the V value. This is the B magnetic field which you are applying to this atom. If this atom will turns around this magnetic field, then it will called as a and parallel. And this, if it will turn back to the magnetic field, then it will become like a half. In the magnetic field, spinning of the atom. Am I clear to you? There is a change in the spinning of the atom in turns. Either it turns from parallel to anti-parallel or anti-parallel to parallel. So there is a difference in the movements. So that will be your energy, del energy. And for one state, if I will write a equation for this one state, what I will write? I will write there is a energy in this molecule, in this atom. Even it can be any proton or electron. We are not discussing the at the bottom of this technique. We are seeing just above cream of that is technique. That E is for this atom I am writing. The E will be mu, that is a magnetic field sine theta. That is the energy for a positive if it is in the parallel direction. And if it is in an anti-parallel direction, this is here like B is going, magnetic field is applied upside, and your spin quantum number. This is a atom. Okay, I will make you understand like this. Okay, this is the eyes of the atom, and this is the mouth. Okay, now it turns just opposite. Now eyes came here, and mouth will goes up. So it is opposite. So atom just become inverted. So for this we will to mu dot b naught. One thing which we are missing, that is a negative signs. This negative signs will tell you what? that is in opposite direction, anti-parallel direction, and this is in your, this will be your parallel direction. You just add this both equation. What you will get? The del E, which is written here, this del E. Okay. So that del E will be what? 2 mu dot B naught sine theta. So what we are seeing, because of the applying of the magnetic field, because of the applying of the magnetic field, there is a change in energy, and this energy you can read. Is it clear? So what understand? What you will understand? You will understand you will find the energy between these two states, and after this energy you will read the frequency, and finding of frequency will tell you the atom, which atom it is, and finally after getting atom you will tell the chemical formula of that atom. Am I clear to you? May I? Okay. Okay, dear student, thank you for being long with me. Up to here, anybody have any doubt? If you don't have doubt, you just give me a like button, so I will be very happy. Just give me a like button or like this. So this is what? This is 100. This like this you can give. I will understand. Okay, now you can understand. Oh, have any doubt? I will take a break, just 30 seconds, and you can tell me your doubt. You can write and you can ask me any doubt. Any doubt is there? No. Okay, dear. Dear, what we understood, this was a one boy who was sitting properly in a erect manner. Okay. After applying a B field, B is what? Magnetic. Have a magnetic into the inverted field. It may turns like this. Now he's inverted, and after being inverted, there is a change in that two states, and that state energy we are seeing. Till now, we didn't found the frequency. So for parallel strand, if the atoms will be parallel, then we will write mu B naught sine theta without negative sign. If it will be in anti-parallel, we will write E minus mu dot B naught sine theta. So do you have to remember this all formula? No, never. No required. Okay. You don't have to remember this formula. Nobody will ask you. We are seeing the concept of this. So after seeing this, you will find you have to find the frequency. This is the important thing. Okay. Then only you will read. So you just make it like this. H nu will be your energy, and that H nu will be like this 2 mu B naught sine theta. And you want what? Frequency? Then write it like this H. So after doing this, what is the important concept you found here? The important concept, if you want to find a change between the two state, you have to give this particular B value. Okay, what you have to give? You have to give this B frequency, and this magnetic field, if you write, there will be change in the frequency, and that frequency you can be used for the like finding the nature of the atom. Okay, now there is an important term which is called a Larmor frequency. Okay, that is a Larmor frequency, and Larmor frequency is very important. Okay, this Larmor frequency is very important. So what does it mean? Larmor frequency is telling you, the Larmor frequency is telling you the magnetic moment around the axis of, so it is telling magnetic field, the magnetic spin momentum around the axis of external magnetic field by an angle theta, and rotates the axis with the particular frequency that is called omega. and that is your larva. The magnetic field which is going up, and the magnetic field which is going up, and the green line which you are seeing here, this green line, okay, this green line, at the different axis it is moving. So this is a spin, it's on axis, and the angle between this red axis, okay, this red around this, no, this, that will be omega, and that frequency which is required to rotate in this green axis, that is called as a Larmor frequency, and it will be denoted by omega. So after, if you'll find the frequency of this value or the magnetic field which will give you this frequency, and then you will apply it to the atom or a molecule. So 2 pi nu. Okay. This is a new frequency for the energy frequency. So you can read this by your own. The resonance condition exposure of the nucleus to a radio frequency radiation set up a magnetic field of a field strength B1 showing in a gray, which has a frequency of oscillation. This is correct. The resonance condition occur when this frequency equal to the Larmor frequency of a spin magnetic moment. Transition between spin state only occur at the resonance condition. This is the very important line. Hope so you understood. Give me the hit button. Is it clear to you? So what is this saying? It will form a resonance. We written na NMR. What is NMR? So it will do the resonance, then only it will be useful only na. Say this is a NMR, or we can say why resonance we are saying, because this resonance only will be useful for this technique. That resonance will be required to convert from one state to the another state. That is the plus half to, this is your plus half. This is not half, 1 by 2. This anti-parallel means this is plus half and this is minus half. So this is the resonance only. Okay, this is the resonance. Am I clear to you? Yes, okay. So please let me know. This is not going to be good. Okay. You have to tell me whether I'm not. See, 100% you can give. Yes, 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 yes. So things we have. Tell me, am I clear? Or if you want me to repeat, you can, what you can do. You can give sign of this. If you'll give this sign, I will understand you are not able to understand. Repeat it. Am I clear to you? This kind of a student you people are. We are about to finish this class fast. Is it clear? Don't think so. Okay, I will repeat it again. Okay, even though you understood, I will repeat it again because you are not saying. From this state, okay, to this second state, what we found the difference in energy. Now, the important thing is that change in frequency will be important. Will give the Larmor frequency, then only it will be so the resonance. Okay, and then only it will transform into this, and this will transform into that will be the important frequency. So you have to provide a Larmor frequency. Got it? And the value and equations you don't have to remember it for GAT B or IIT JAM or MS references. But if you are preparing for the CSIR, so you have to remember this. Am I clear to you? Am I clear to you? This is the important concept. You have to give the hit button, otherwise it will be not understandable that you are clear or not. Now, the Larmor frequency you understood. After Larmor frequency, the important thing that is called chemical shielding. Shielding. And what is this chemical shielding? Suppose beta, There is a hydrogen atom. This is the atom of the hydrogen. And there is a carbon atom. This is the atom of the carbon. If you will apply, if you will apply the B magnetic field, this B you want to apply for the hydrogen only. But the same time, this atom, this carbon atom may have the magnetic spin downward. It is having a magnetic spin of the downward, and it may hydrogen have a magnetic spin of the upward. It This magnetic spin of the carbon may affect the spinning of this hydrogen. Am I correct or not? In in presence of B magnetic field, this carbon magnetic spin may affect the hydrogen also, and this magnetic field may affect the carbon spinning also. Am I correct or not? But you want to see the hydrogen spinning. Yes or no? Say yes. At least you can write. It will be going to be very boring if you will not reply. Okay. Too tough. Shall we? This you understood. This magnetic field affect the hydrogen. You want to see the spinning of the change in the spinning of hydrogen in this B magnetic field. But this will also affect the spinning of the carbon atom also. Am I saying wrong? No, na. So that will shield. The chemical shielding means what? This carbon chemical compound will shield the like spinning. So that is called the spinning, like chemical shielding. That will called as a chemical shielding. That is a very important concept. That is the very important concept for this. The whatever we studied till now, that is a experimental values, but from where the question will be asked, from here only. You have to tell me whether it is clear or not. Otherwise, we can stop the class here only and we will read separately. Few students are there. You just say yes or no. It's not coming or what? Don't know. Teaching silently without a student response, it is a very dumb task for me. So hope so. By hoping that you are understanding these things, I am continuing. Again, B magnetic field will be shielded because of the spinning of this carbon also, and that will called as a chemical shielding. And this chemical shielding will be affect this magnetic field. Okay, this will affect the magnetic field. So suppose you given the B1, then the effective magnetic field will be what? The effective magnetic field will be about B1 minus 1 minus sigma. This is a sigma is a shielding effect. Okay, shielding constant, shielding constant. Okay, so it depends on the which constant. It depends upon the this R. Take it as a R, a functional group or any molecule which will affect the magnetic field effect. Okay, so that will be always that will be always different for the other molecule. The what we are saying, the origin, not origin, the base, or we can say the tetra methyl saline will be taken as base, or what we can say, it is a like comparative value. Comparable, we will compare according to tetramethyl saline. Its value will be around 0. It won't affect. So if you'll tetrasaline will be there in a molecule, and if methyl will be there, then will be like, if example I am giving, if methyl is there, then chemical shielding will be minus 0.5. to 1. Okay. And if benzene is there, its chemical shielding is highest. This is the it is the highest chemical shielding it will show. Am I clear to you? So the effect of the magnetic field of nearby nuclei on that of nucleus undergoing transition is known as a chemical shielding. Hope so you understood by this line. And now there is a I think there is a lack of latency. Okay. Now you just see what? How you just see that value of I for a element. So for different element, the value of the I will be different. For the different element, the value of I will be different. So these are the abundant molecule which is present in our will be available and P31 N50 plus half value. And like N14H, their spinning quantum number will be 1. Only oxygen and sulfur 32 will have the spinning quantum number 0. So this is the important thing. See, by using NMR, you can find the isotopes also, okay, which isotope is present. Okay. By using NMR, you can find the dimagnetic or paramagnetic molecules also. So species, like it is very specific to the molecule. Am I clear to you? Am I clear to you? Say yes or no. Not clear, then also good. If it is clear, then also good. So I want to show you two things how we will explore this, and ultimately I will tell you the most important thing. So this is our setup. So this all things, whatever material we are taking, this is from the it is available in the book. Which book it is? That is a David Sheehan. If you want, you can go and read from that David Sheehan. It is a nice book, but content is abundant. For GAT B and MSc student, I will not like GAT B and IIT JAM MSc entrance exam preparing student. I will not suggest go and read that David Sheehan. But those who are reading for the CSIR, they can read and understand by themselves. Also, it is easy and important. Okay, so this is the power of magnet. Then you are using a accessory magnet. Then you have a probe, wire coil, transmitters. Is a Z axis, Y axis. Where is X axis? This is the X axis. Okay. So the thing which you are seeing, this is a Z, Y, X axis. So outline of a so this is a probe. Any molecule. Suppose you took any dihydrochloric phenoxic acid. Okay. Or you can take or any enzyme, carboxylic acid. Okay. Enzyme you take and you put it to this coil. Okay. What you'll do? You'll put into this coil. So this is a powerful magnet. This is the full magnet you are applying, and this have a magnetic field. Suppose this direction. They have the magnetic field about this direction. Super. They are so this will have the magnetic field about this direction, and there is a accessory magnet which is putting down, and there is another accessory magnet which is putting up. So once this magnetic field will be applied, there will be change in what? There will be change in the spinning. As you seen, there is a change in the spinning of the molecule, that atom specific. Okay, there will be change in the quantum number. and there will be, after the change in the spinning, there frequency. The value of that frequency is what? 2 mu b naught sine theta by h. And that frequency should be matched with the Larmor frequency. Okay. And if Larmor frequency will be achieved, then it will give you the resonance. If resonance will be achieved, then if resonance will be achieved, it will be easy to detect that changes. Okay. So again, I am saying there is a two powerful magnet. There are two accessory magnet which is put here, and here at this spot you are giving your isocitrate dehydrogenase. Suppose one enzyme I give. This isocitrate dehydrogenase will change the spinning, that magnetic quantum number. The value of the will be this, as I said, already we studied above. Now, in spinning, the because of this, uh, the resonance will be occur, and that resonance will be read by this detector, and detector will show you the computer. I would like to ask anybody to read this if I was taking online Google Meet class, but I will read for you people. Okay. Outline design of NMR spectrometer. The sample is placed in a tube called the probe. Okay. This is surrounded by a wire coil of a powerful magnetic field B naught is generated in the x-axis. Radio frequency radiation is generated by the transmitter. Got it? Which generate a magnetic field oriented along the y-axis. When the frequency of the field in the same as the Larmor frequency, the resonance condition met. This is the important for this. Okay, Larmor frequency should be achieved. Okay, so the resonance will be occur. Okay, just say 1 minute. I want to show you one thing. Then hit like button. So I will be very happy. I will be more enthusiastic to teach you more details. Okay. Here we studied the when the frequency of this field is the same as the Larmor frequency, the resonance condition is met. Absorption of a radiation induce a current in the wire coil along the z-axis. Okay, the at the z-axis the current will be induced, and then which is electronically detected. This current is proportional to the absorbance. Okay, so this current which is absorbed then tell you the this line, important line. Absorbance of the radiation induce a current in a wire coil along the z-axis, which electronically detect. This current is proportional to the intensity of the absorbance. Got it? This is, and hope so you understood. And now I will share from which they will ask the question. Okay, this is the important thing. Okay, everything was important earlier. The techniques concept we understood. Now we are seeing the end result. What you will see in this detection. After detection, computer will show you this type of structure, And as I said, TMS will have the less shielding effect. What I said, TMS has the less shielding effect, and this TMS is what? This TMS is your tetrasaline, tetramethyl saline. Okay, saline. This is your observing origin, or we can say. You can understand by this diagram. Is it anything relatable? Yes, it is a relatable thing. Okay. Now I will tell you the thing. You can understand anything? Now, at least now you can give the hit button, like button, something. Sindhu Kanthala. Okay. Please give the chat. In chat, you give me the 100 plus. Okay, sir. Bye, sir. Tata, sir. Something. Medal. Like this. Good. So, up to here, you understood? TMS have a zero value because it is not deflecting the magnetic field. TMS, as we found. So this will be the peaks. So they will ask the peak number of the peaks for the any number of peaks. This is the important formula, you have to remember it. Okay. So how many number of peaks you will get in the following thing. So the formula will be what? The formula is number of peaks is equal to 2 into n into I. This is a small space. Okay, let me set it here. Okay, 2 into I plus 1 plus 1. This is your number of peaks will be there. So I will tell you one example. You have to tell me the another example. So this is the important equation. You just remember it. Till now I didn't highlighted any equation. Okay, I am highlighting this only for some reason because it is important. So okay, so suppose there is a CH2. Okay, here CH3 is there. Yes or no? And here OH group is there. So this we will not count. We will count this hydrogen atoms. Okay, how many hydrogen atoms will be there? So for this three, for CH2, how much you will get? For CH2 in coupling with the CH3, if you will see, the value will come like this: C bond and H and H. Okay. So here N is what? N is a number of nuclei. How many number of nuclei you are coupling with the CH3? Number of nuclei. So it will be 3. So the number of peak is equal to 2 into 3 into half. This is a your magnetic quantum number. Okay, that for different values will be different. So 2 and half, 2 into 3 into half plus 1. How many peak you will get? How many peak you will get? You can answer there now. In chat you can answer. Please. A humble request. How much you will get? The number of peaks. What will be the value, beta? You cannot write here in the chat box. It was not visible. Here. What the value you will get? After this, solving this equation, you will get how much peaks? You can write there, na? You have to solve the equation. That's it. So you will get the 4 peaks. Are you people there? Or I am teaching myself only. So if you'll see for the CH2, as we said, for the CH2 coupling with the CH3, the peaks will be how many peaks? 1 will be the peaks. Total 4 peaks you can see. Okay. So like that, proton NMR spectrum of ethanol. NMR spectrum consists of a plot absorbance intensity and versus a chemical shift. This is the also important thing. Absorbance intensity and the chemicals. The Peaks arising from each of the three types of a proton in structure are labeled. In the case of CH3 and CH2 group, peaks multiple peaks arise as a result of the spin coupling. Butler Hard inorganic chemist